Howdy everyone, and welcome to our first video on tessellation. In this video, we'll be talking about the definition of tessellation and tessellating simple regions. So first of all, what is a tessellation? A tessellation is a covering of a plane with congruent regions with no overlaps and no gaps. So congruent regions is, for now, we'll think about like shapes, right? Like triangles or squares or hexagons, as this slide discusses. So we'll pick a region, some stuff in an area, and we'll copy that region over and over and over. Congruent, same size, same shape, same contents. But when we click them together, we can cover the whole plane, so no parts of the plane are not touched. So it goes forever, infinitely, right? Because planes are going forever. And it does it with no overlaps, everything's touched, and no gaps, so the shape doesn't have to go on top of itself in order to cover the whole region, right? For example, look at this triangle. This is one possible region. We're going to copy this triangle, and then we're going to color in the regions and repeat those, right? And notice that they click together nice and perfect. Not every shape is guaranteed to click together like that. For example, pentagons can't tessellate. If I try to make multiple pentagons and tessellate them, you're going to notice I am left with just a little bit of space that I can't easily cover with a pentagon. If I try to make another pentagon to cover that space, notice how it overlaps, right? So there's this triangular bit in the middle. I could shove these together, click them all real close, but they won't click as nicely as triangles do, right? So what is so special about these triangles? What causes them to tessellate? Well, let's examine it through the example that I picked out, just 6 of them, and we can see. To tessellate, I need to cover the entire plane. So I need to go 360 degrees, right? I need to go all the way around to cover it. 360 degrees. Can I do that with these triangles, right? Let's examine. I need to go in every possible direction, right? All the possible directions to be able to cover the whole plane, right? So I need to be able to go everywhere, 360 degrees. Well, if I look at this, the triangles appear to click together to form 360 degrees, right? They do seem to cover the whole thing. Squares will do that, hexagons will do that. So what is so special about squares and hexagons that they do that? Let's investigate, right? I'm going to look at the angles inside of my triangle. Right, so I'm just going to demarcate those. And when we tessellate, remember, we're using congruent regions. So this angle is repeated, right? It appears in all of my regions, everywhere. And the same goes for the other 2 angles. Those are just the same angle elsewhere. You see? And lastly, my purple. Now you'll notice when I do this, the 3 inner angles of my triangle all add up and they click together. You might remember that triangles, their inner angles add up to 180. And I can see that when I rotate and click together and translate all the triangles so each of the corners is touching, it goes halfway around. Well, if I do it again, 180 plus 180 is 360, right? So it covers the whole gamut. I know because the inner angles of a triangle add up to 180 that if I just touch all the corners of a triangle to each other, I get halfway around, and do it again to get the whole way around, right? Now let's examine the other simple shapes and see that they have very similar patterns, right? Squares, pretty easy. We can just check out 4 squares, right? Put those all together. Remember, the inner angles of a square add up to be 360, right? So if I put all 4 corners, bottom left, bottom right, top left, top right, as I did here, that's going to be 360 degrees all the way around, right? It goes the whole way around. Now, hexagons, you probably don't remember the interior angles of a hexagon, and you don't need to, right? But you'll notice, again, when I make a hexagon, I make 3 of them. Oh, that's a pentagon. If I make 3 of them, right, they would also click together real nice, really nice clicking, right? And they would do that. And that's because each of these angles is 120, so 3 of them form 360. However, there's another. Now, that's tessellation for simple regions, right? And again, not every region tessellates that way. The only simple regions that tessellate are things like triangles, quadrilaterals, and hexagons, right? In the next video, we'll talk about what are some more intricate regions that tessellate, things that are more interesting than just triangles, quadrilaterals, and hexagons. I'll see you then.